first lesson in our expressions unit, and this one is on variables and expressions. It's a good review from what we saw in 6th grade, the idea of substituting a number in place of a variable and then solving the problem. So our essential question is, how do we evaluate algebraic expressions? First thing we got to talk about is multiplication, and more importantly, how we show multiplication. We want to get away from using the x for multiplication because x is oftentimes going to be one of our variables, and we don't want to have to stop and ask, is this an x or is this a multiplication? So from now on, we're going to try and use anything but x for our multiplication. So here's a couple different ways you might see multiplication shown in a problem. When a number and a variable are right next to each other, that's really code for 6 times d. 6 times whatever d happens to be. Same thing if there's more than two pieces put together. When they're right next to each other, that is code for multiplication. So it's 9 times whatever x is times whatever y is. Sometimes you'll see that shown with parentheses instead. When a number is right next to a set of parentheses, that's really code for 7 times whatever happens to be inside the parentheses. When you have two letters next to each other, again, that means whatever m is times whatever n is. So if it helps you, write that multiplication sign in between them just to remind yourself. When we see our exponents, remember that's code for you're going to multiply this base, this a, 3 times. So this is really a times a times a. But when you're writing it out, we really want to start to see you use that dot, or even better, start to use parentheses to show multiplication. Get out of the habit of using that x. We don't want to use x anymore because we don't want to be confused about whether it's a variable or a multiplication sign. All right, so now we're going to put this to use. When it asks you to evaluate an expression, that means plug the numbers in place of the variable and then actually go ahead and do the math. We want you to find a final answer. We want you to actually do the whole calculation all the way to the end. So here it says a is equal to 4, b is -6, and c is +5. All we want to do is wherever we see that variable, we want to plug the number in place of it and then go ahead and do the problem. So here I have 2 outside of the parentheses. That means 2 times whatever I get in my parentheses. I see a is 4, so I'm going to rewrite it as 4 plus 3. And then I know I'm going to multiply by 2. 4 plus 3, remember we're starting the parentheses, that's 7 times 2. 2 times 7 is 14. Notice our note down there. You must fully rewrite the problem, plugging in the numbers in place of the variables, then show each of your steps in your calculation. Even for the easy ones, we need to see that you know how to show that work and show your steps so somebody else could follow how you got that answer. Here, 4a means 4 times a, so 4 times 4, I'm going to use my parentheses to show my multiplication, plus 5c. That doesn't mean 55, it means 5 times c, which is 5. 5 times 5. Rewrite it, and now we follow order of operations. 4 times 4 is 16. 5 times 5 is 25. And then we add them together, and we get 41 for our answer. But it's step by step all the way through so somebody else could follow that work. This next one, I threw in to be a little tricky. Notice the exponent is on the c, so c is what is being squared, and then we're going to multiply it times 2. So this is going to be 2 times 5 squared minus b. b is -6, so minus -6. A little alarm should go off in your head. Anytime you see subtracting a negative, change it to adding the opposite. Now we're going to do our exponent first. 5 squared is 5 times 5, which is 25. And then we rewrite the rest of the problem. Now we multiply. 2 times 25 is 50, plus 6 is 56. But no cutting corners as you work your way through the problem. Show all that work. Last one, a plus b. That big fraction bar here is really code for divide. You're going to take the whole top divided by the whole bottom. So a is 4 plus b is -6 all over 3c. That means 3 times c, or 3 times 5. 4 plus -6 is going to be -2. 3 times 5 is 15. When you go to do your dividing, if it divides nicely, go ahead and do your dividing. If it comes out where 2 and 15 are not going to divide nicely, it's okay to leave it as a fraction. Here it's going to be negative 2 15ths. Okay? We couldn't divide it nicely, so it's okay to leave it as a fraction as long as it's in simplest form. All right. Last part. So in our notes, we're going to do a quick review of order of operations. So remember, we do parentheses first. So anything in the parentheses. Then we do our exponents. Then we're going to do our multiply and divide. Notice they're together. Okay, and I want all this written in your notes. I want the pyramid drawn in your notes as well. And then we're going to finish with add and subtract. So we reviewed this earlier in the year, but we're going to hit it again right now because you've got to follow order of operations in every problem, especially these variable and expression problems. So anything in parentheses, then any exponents, then any multiply and divide from left to right, and then adding and subtracting from left to right. Meaning whichever adding or subtracting comes first, we're going to do that first when we get to them. So let's see this in action. These are going to be a little bit more involved, so really focus on rewriting them properly. Y squared, so 4 squared, we're just plugging the numbers in place of the variables, minus, and then 5z means 5 times z, in this case negative 2, plus x, which is negative 3. So we're going to start in our parentheses. In the parentheses, you still follow order of operations. Multiplying comes before adding or subtracting, so we're going to do that first. 5 times negative 2 is negative 10. But my parentheses are still here because I haven't finished what's in the parentheses. I keep doing all the work in there until I'm down to a final answer. Now I'm going to add negative 10 plus negative 3, same signs, add and keep. And I rewrite the rest of the problem. Here I see subtracting a negative, so I make it adding the opposite. Parentheses are next because I'm all the way finished with my parentheses. So exponents, 4 squared, 4 times 4 is 16, plus 13 is 29. But following order of operations all the way through. Next one's a little longer, 7z, so 7 times z, 7 times negative 2, plus 8x means 8 times x, which is negative 3. The slash is divide, so I'm going to divide by y, which is 4. And then I'm going to do minus x cubed, so x to the third power. X is negative 3, so I'm going to do negative 3 to the third power. Okay? Some of you might be tempted right now to make this adding the opposite. Don't do that until after we're done with the exponents. Let exponents happen before we do any of that adding the opposite part. So there's no parentheses here. And what I mean by parentheses is there's no problem in the parentheses. Remember, in this case, the parentheses are just showing multiplication. It's just a different way of writing multiplication. There's no actual problem in a parentheses that we need to do. So we're going to do our exponent. Negative 3 to the third power is negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is positive 9 times negative 3 is going to give me a negative 27. So I rewrite the rest of it. Yes, it takes a lot of work, but it's also a very good way of making sure we don't miss anything in the problem. Now that I've taken care of my parentheses, now it's okay to make this adding the opposite, because we never know when that exponent was going to change it back into a positive, and we don't want to throw things off. So there's no parentheses. We took care of our exponents. Now we're ready to multiply and divide, and we're going to do that left to right. So multiplications first, because it came first in the problem. 7 times negative 2 is negative 14. 8 times negative 3 is negative 24. And I rewrite the rest. Now I got to take care of that dividing because it was kind of the last in the line. Negative 24 divided by 4 is going to be a negative 6. And now I'm left with just my addition. So I just move them across left to right. Negative 14 plus negative 6, same signs, add and keep, is negative 20 plus 27. Here they have different signs, so we're going to subtract them and take the sign of the higher number. So we get an answer of positive 7. But show that work all the way through, step by step to the end.